Welcome to MyProjectBazaar.com. Our project title is an energy efficient reliable data transmission scheme for complex environmental monitoring in underwater acoustic sensor networks. Abstract. It is important to ensure the reliability and efficient data transmission in underwater sensor network. For considering the importance of energy consumption in WSN, we propose an energy efficient data transmission scheme called EGRC, that is energy efficient grid routing cubes in underwater sensor networks. It takes the complex properties of three-dimensional changing topology, high propagation delay, node mobility and density, as well as rotation mechanism of cluster head nodes. We split up the entire network as small cubes and in each grid elect one CH node. Moreover, EGRC utilizes residual energy locations and end-to-end delay for searching for the next hop node to maintain the reliability of data transmission. Also, we have to implement ANOVA process for testing the statistical information of the node. So, in this process, we have to done the proposed work of this paper. Let us see the flow of our project. First, WSN is formed. Then we have to form the cluster based upon the coordinated region values. Then the cluster head is selected based upon the EGRC algorithm. If the cluster head is selected, we go for ANOVA implementation. That is, we have to do the statistical test. There are three statistical tests. First one is Fisher test, next one is Techie test, and next one is Petlet for shortest path routing. And for these three process is done parallelly. We have to done the data transmission, and the performance is evaluated based upon four parameters. First one is delay, and then packet delivery ratio, and throughput and energy. Let us see the output of our project. First, we have to open the terminal window. Before running our project, first we have to set the path for our project. For that, type cd gedit space /bashrc. In that notepad, replace this ns 2.29 with 2.34. So our package is, we have implemented our that ANOVA process in our advanced version of 2.29, that is ns all-in-one 2.34 package. So replace all, and we have to select this NAM 1.11 as 1.14. Then close this and type cd space ns all-in-one 2.34. Then type make for configuring the file. Then close that. Then go to our code file. So type cd space code ns space main.tcl. So we have to calculate the position of each node, and we have to do the ANOVA test. There is for statistical analysis. So in order to achieving this, we have to did three types of test. First, Fisher test, birthday test, and Techie test. This is called our NAM window, that is network animator window. So our process is WSN, that is wireless sensor network. When we click on this play forward button, it will work. This is for simulation speed we have to increase or decrease the speed. Our process, we have to select the cluster heads depending upon the energy. So these nodes are act as a cluster head, and our process is routing process. We use AODV, that is on demand ad hoc distance vector routing, and it sent at 106 byte packets are sent at a time. So if any process wants to send the information from source to destination, it's sent via the cluster head nodes. Now the source node of 1 wants to send the information to node of 29, so this communication is done via that cluster node. So our cluster, in one region it collects the information is collected with the cluster, and other in for that other region it is given to that other cluster head. So for that communication we have to easily identify which cluster head have that node information, and easily reduce the delay constraints. For running our graph file, type gnu plot space thr.plot. Thr means throughput. In existing system is depicted as this red color, and our proposed system depicted as this green color. So we have to compare mean node speed versus our average throughput per flow. So in our proposed system we achieve more throughput than the existing system.